Picture this, you are a developer diving headfirst into the AI revolution. You have scoured the latest models, Grok for its wit, ChatGPT for creativity, Gemini for smarts, and even open source gems from Hugging Face. Hours of research finally pays off. Your AI powered app is live, chatting with user and feeling futuristic. But then reality hits. Traditional security tools useless here. How do you spot if your model hallucinates facts, leaks sensitive data, or falls for sneaky prompt injections? Your app is exposed, and so are your users. Enter Garak, the open source LLM Vulnerability Scanner that's your new best friend in AI red teaming. Let's lock down those models and build fearlessly. Garak stands for Generative AI Red Teaming and Assessment Kit. Although it was started by an individual, now it's backed by NVIDIA. Garak checks if an LLM can be made to fall in a way we don't want. It probes for hallucinations, data leakage, prompt injections, misinformation, toxicity generation, jailbreaks, and many other weaknesses. And the best thing about the tool is it's open source, as it has an Apache 2.0 license. In this video, we'll see how you can set up Garak to test your own applications. While Garak can scan the text and generative models directly from spaces like Hugging Space, in this video, we'll focus mainly on how you can run it against an API web app. So let's start by installing the application. Now, there are a number of ways how you can do this. Either you can install it globally, or you can use UV for your virtual environment. I will go simple and create it using VENV or virtual env to set up Garak on my machine. As you can see, I have an Ubuntu machine, and I will quickly create a directory and then follow the installation commands. This is a quick installation guide that is mentioned here, but Garak also has very detailed documentation that you can go through in order to see how you can use Garak. As I mentioned earlier, of course, you can use the model types here. But like I mentioned, we will be using the REST generator, which will help us to scan our application. Also, in case you are building an AI-based web app, this is what you will want to do. All right, so let's quickly open my terminal, and I will go to the desktop, and I will make a directory here, and then let's go into that directory. We make it bigger, and now I will create a virtual environment. So let's see if I have virtual or VENV installed. I don't. So hopefully, if you have Python version like me, you can do Python -- version. I think I'm in Python 3 -- version. And you can see I have Python 3.12. And let's see if I have pip. Yes, I do. And I will use pip to install virtual env. So I'll simply do clear pip install virtual env. Or I can do pip install venv. I think that's better. And since I'm on Ubuntu and the environment is externally managed, I can install it via apt. So that's what I'm going to do. I'm going to do sudo apt install Python 3, and then I think that's how it is. Yeah, this is venv, and let's see if it also has virtual env. Yeah, So you can use either VENV or virtual env, whatever you prefer. I'm going to use virtual env. Put my password here. And it's installed. I'm doing all this just to put my Python environment separate from my common Python environment. That's a really good practice. Every time you work on certain Python projects, I would recommend you either use virtual env, VENV, or UV to create this separate environment so that your two different applications dependencies don't conflict and create issues. And you can also have different versions of Python that way. I've seen most people nowadays use UV, which is also a very good Python environment and package manager, if I'm not wrong. But I mean, it's too overwhelming for me. I'll just go with the classic virtual env. So let's go back and I will do virtual env and I'll name it Garak env. And now if you'll see here, I have this Garak environment. In order to activate it, I'll just do source and Garak env bin activate. And if now I will do which Python, you can see it's our directory. All right. And now we can follow the documentation. Let me go back. And let's go to the documentation. What we are looking for is, guide. All right, so we'll go through this awesome guide. It mentions what is Garak. Then we'll go to the features, and we already know what is LLM security, so we will move on to installing Garak. And I think that's the best way of installing it. As you can see, it clearly mentions that you need to install Python version 3.9 or higher. Let me go back. Yeah, you need at least Python 3.10 or higher. So make sure your Python version is 3.10 or higher. Right now, I think it's 3.12 currently as of recording this video, but please make sure that you have that dependency installed correctly. Great. So we will install it with pip. I will copy it, go back to my old terminal, I think, which I closed. My bad. So let's go again to desktop. Correct demo. Again, I'll do the source bin activate, and then I will paste the command. Until it installs, we can quickly check how to do my first scans. And this is a really neat way of checking all the probes that Garak has. Probes in Garak are like attacks or test cases that Garak uses to red team an LLM. So it has separate categories. Once you list those probes, you can see it could be ART, which is AI red team, AI red team toxicity, and then you can even find some classic attacks or test cases that are used in security, like cross-site scripting, as you can see here. Of course, you can then create your own probes as well if you want to use along with the ones that are provided with Garak. And one important thing, so for all these probes, you don't need, so for most of these probes, I should correct myself, you do not need to have an LLM in the back. So you'll just would your system under test or your application that you developed would have the AI large language model. In order to test it, you will use Garak, but unless you are using reactive probes, you do not need Garak to be fed on a large language model. And now it has installed Garak completely. I just want to make sure that I tell everyone, please make sure you have enough storage, as Garak downloads a lot of stuff which may take considerable amount of storage capacity. Alright, so now since we have it downloaded, let's quickly check the Garak probes, and that will also tell us if Garak is installed correctly or not. So again, just making sure that I am on the Python version that was from the virtual environment, which it shows here that it is. Let's quickly write the command to check all the probes, which is python-m Garak list probes. All right, and it shows us all the probes that it has. So how do we use it for our application, or how do we use Garak in general? Let's quickly go back. And as you can see all the probes, you can also see you will find all the options with --help. Let's use that. And let me clear this. And here you can see all the options that Garak has. We will go through the documentation. Let's do a basic test to make sure Garak is running correctly. And as you can see here, this is a super simple self-contained test to check that Garak's code is running okay. We put a model type test blank and probes as test. This is just to check that our Garak installation is correct and there are no issues. So let's do that. Oops, my bad. I should have not copied this. And here you can see everything is good. It generated an HTML file which we can quickly access. And you can here see the entire HTML report. Moving forward, let's go back to our application. I will monitor the network details. And right now you see it's doing a get to 8001. I will ask it a simple question. Hey, how are you? And it gives me a response. If you see here in our network tab, you can clearly see that I am sending a GET request and I get a response of my chatbot. When I go to this request, you can clearly see that my request was simply, hey, how are you? And if you'll see the raw JSON file, that's it. And if you'll see the headers, the request, even though here it's at port 8001, it's actually making a request to port 8000 on the same IP. Let's see it a bit better using a man-in-the-middle proxy. I have Burp Suite installed, so I'll simply open that and we'll do the same thing again. So let me open Burp Suite. I use temp project, start Burp Suite, And let me copy the URL of my awesome chatbot, which is running on my local server here. And I'll quickly open it in Burp's browser. And we'll ask it the same question. Hi, how are you? And while it's sending my response, we can quickly check our HTTP history. And you can see the request is going to port 8001, where if you render, it's actually sending me a response of the HTML, but underneath it's trying to send a request to port 8000. And if you'll see, this actually is a JSON file, which basically is making an post API request to this IP and port. And this is a prompt that we asked him. And you'll see this is the response that I get. So essentially, even though we see the front end, in the back end, we see that these are the API requests that are my application is sending to the LLM backend and getting this response. Let's quickly test it. So let me right click and send to repeater. And for those who do not know how Burp works, once you send it to repeater, what essentially you'll be doing is you will be sending a raw request by editing it. So if this is an actual API request that's going from my application to the backend, and then this is the backend API that's being called from the front end. If I change these, I should get a response from my LLM directly. So instead of that, what I will do is tell me a good dad joke. And now the API response should give me the response from the LLM. So I will run this. And you can see here, I got a response. Why don't skeletons fight each other? They don't have the guts. This is especially relevant for the folks who are doing a black box testing and do not know how the API exactly works. So you find your way back from the front end. But in case you are doing a gray box testing and you know the exact API call that makes this, it will become even easier. So let's see how we can use Garak here. So I'm going to open the Garak documentation. Let me go back. And let's search for Garak REST generator. Or if you go back to the official website, we can see it there also. But here we see that we need to provide a JSON file in order to run it. Just to be sure, let's go back to the Garak official website. And it redirects us to the same documentation which shows the JSON file. So let me start by creating this JSON file. I will copy this, go to my terminal, and I just have the environment here. So I'll quickly do a JSON file. Let's make it config.json. And this is where I will paste everything. And then let's change all the details. So our service name would be Garak demo. And then we need to give it a URL. In our case, it will be /chat. So I can simply copy either this, or instead what I would like to do is go to the proxy and copy URL. and hopefully I copy the right URL. So let me change this, and we know that the method is post. Authorization key, we don't have anything. So if you want, you can add all your headers here. Let's just make it blank, or it's better that I just put a generic header. Let me make this. But remember, ideally, if you have an authorization key, so maybe you have a JVT token, or if you have some other form of authorization, all those authorization headers will come here. So if you have an authorization bearer token, for example, you can just replace it with authorization bearer and the value of your token. Since we don't have it, I will simply delete it and enter the header information that we had. Of course, these should be in double quotes. Or since we do not have any specific browser, I can just name it Garak. All right, now we need to find out, and this is important, the input. This input is where Garak will put all the probes that it will generate. So it will figure out, okay, this is the individual request, grab all the probes that it had, where if you remember, we saw from running the command Garak -- list probes. Those probes would be used here. So you will see tens of requests all being sent to this input. And then you need to make sure what exactly is the response field, which Garak will then verify to know if the prompt injection actually worked or not. In our case, the text field is actually prompt. So let's change that. Let's change this to prompt, and then leave the input, and our response field, which again is a JSON, is just called response. So if you go here, the response JSON field is simply response. Let me make it side by side so you can see it clearly. Prompt is our input field that you see here, and the input will be what we will get from Garak. And once we send this input, the response will get in a JSON file in a field called response that you could see here. So response yes is true that it's in JSON, and then the response JSON field is called response. Let me quickly save that. This again will change depending on your application, however your developers or how you have actually set up your API endpoint. So I will save it, and now you can see my config file. I'll minimize it and let's make it bigger. And another thing that I would like to update is because I'm running my app locally with a local LLM on a very low-end machine, the web app would take a lot of time to respond. So I will add some more values to my config.json file, and to see these values we can go back to the browser, and here if you'll see it, you can also put a request timeout. By default it's 20 seconds, but since I told you my server is super slow, so I will change it to 200 seconds. So let me close this and let me add that and the value and put it to 200 seconds. Save this, and now you can see my config.json has a new option. Let me clear this, and now we can run our scanner finally. Before we do that, let's try to understand how Garak works. So we saw earlier Garak has a bunch of probes, and if we check them, they are 199. So it might be 198, 199. I think it will have one or two extra lines. But essentially, what probes are? They are categories, and each category or each probe would have multiple prompt injection attempts. So when you will run them, someone would have one prompt injection, someone will try two, and some would even have as much as 256. Of course, if we check the Garak manual or documentation from the website, you will see that there are ways of stopping the number of attempts. There are also ways of running parallel attempts so that you can have your scans faster. The REST generator supports this. But if we do that, I'll try to explain how big the scan would be. Let me quickly start drawing like another famous YouTuber. So here you have Garak. Now Garak has multiple probes. So there could be XSS related probe, there could be data exfil, toxicity, and whatnot. Every specific probe would have multiple prompts. So there will be one prompt to try XSS a certain way in Markdown, another one to try certain other way. So you can either use all of these prompts to run to one REST generator, or you can put all of them. This is REST generator, which basically goes to my app, or you can directly use a model from Hugging Face and test it. But what I'm trying to say that the way it will work, it will be number of probes into number of attempts for each probe. And because Garak is an LLM vulnerability scanner, it runs it at least 5 times in order to give you an average. As we know, in AI, you don't get exact responses when you add certain prompts. Similarly, for prompt injections, they would run the same probes into attempts at least 5 times by default. So you can imagine running a scanning campaign on any app will be very taxing and would use a lot of resources. These loops that are run for each attempt are called generations. And this is what we will try to reduce. Similarly, instead of by default using all the prompts, we will use only one specific prompt that my app can handle. So let's get back to the documentation. As it mentions here, we already added request timeout, and now if you want to run, we can simply use Garak -- model type rest -g example service.json. If I do that, it will run everything, I think sequentially, and it will use all the probes, and it will run every generation 5 times. So let's try to run this by default, and I will add my config.json here, and let me stop it right there. And you can clearly see there were 51 probes, and if you pause the video, you would have seen that it was 0 of 5 attempts, which means it will be total of 5. And these are all the probes that are being run. The first one that went was props.ansi escape, and it had 51 prompt injection attempts. So very important to note the amount of resources this will consume when running a scan, which is quite typical for any other non-AI related scan as well. The scanner would be resource heavy, and based on how you set it up would take a lot of resources. Now, moving on, we will only use a certain probe, and we will also only use a certain amount of generations. So again, let's quickly see if I run it by default. You can see this is 0 by 51 by 5. Of course, I didn't add parallel, which I could have. As you can see, it also mentioned that we could run all of this in parallel, but I will run sequentially, and I will use certain probes. So let me check all the probes again. Garak probes, list probes. So let me do that again, and I will use string assembly data exfil. So I will copy this. If we check the help page again from Garak, it's Garak -help. And you can see that there are generators, generator options. What we are looking for is -- probes. We already saw the model type. We won't be using parallel attempts. But the one option that I'm looking for is generation, which is -g. So let's do that. I put my config.json. I will put -p or - probes, and then I will paste it. And then what I will do is put -g and 2. So it will run each test twice. So one probe, I think this probe has 2 prompts. Both of the prompts would be run twice, so a total of 4 prompts would be sent to my application, and hopefully it won't die. Yeah, as you can see, 2 prompts and 2 generations, which means it will be ran twice. And as you can see here, one of them went through. Seems like it was good enough. You can also see where our logs are. So once the scanning finishes, we can actually check it out. You can also see where our report is, and once everything is finished, it will also generate an HTML file that we could view, and we could see how the Garak results actually look.
A few moments later.
And now you can see our scan has finished. It had a 75% of success rate. And now we can see the details in the report. So let me quickly copy this in the local directory, which will be cp. And let's name it garak.html. Similarly, I will copy the logs, or we can check the logs directly. But let me copy the JSON file also. JSON. And also let's quickly check what exactly happened in our logs. And in the logs, you can actually see what Garak sent to our system under test. And you can see the details here. The probe done an object when it started. See, there are some errors. Let me clear this. Let's open the files that we have. So let me open garak.html, and Firefox should open this. Yes, and you can see there was a 25% success rate with critical risk, and this means yours, or in this case my website, is not secure. Let's look at the JSON file. So let me leave it here, and let's do a more or less of, that doesn't matter, of garak.jsonl. And here you can find the details of what exactly was being run. Let's make it a bit pretty, as we see the actual prompts there. Let me open it in code. I don't have code. All right, so let me make it prettier somehow. But we have Codium, so let's open that. And let's open this. And here we see all the details. View it word wrapped. And here you can see our actual prompt. I think we can make it pretty. Let me try that. And let me just format it. And now we have it in a very nice and clean JSON format. Exactly what prompt injections went through. And you see this is the init. This is the attempt that I was talking about. It ran this text, and you can see the detector results here with all the details. So it was taking multiple turns. And here you can see one of them worked. And this is when it ran the same thing again. And this time both of them worked. And you see the details that only one of them passed out of 4. And as we saw, 3 of them were able to do the prompt injection. Now, this might look confusing, but there is a very good documentation of how to view the results. So you can basically also check that out, which is not this, but I think I had copied it. Never mind, we can simply go back. So I think it's docs.garak.ai, and let's see, reading the results. And just like us, they had this results. And then if you go line by line, says when Garak started, what generator, which probes is going to use, and it had 20 generations, but if you remember, we only did 2, and the failure rate was 15% here. So unlike ours, which was way worse. So from this you can understand that this only gives you a percentage. If you go back to our JSONL file, for those of you who do not know, JSONL stands for JSON per line, which means each line in the file is a separate JSON. So instead of what I did, viewing everything together, let's view it line by line. So let's start with attempts, so we can check the first attempt. And here you can see there is a multi-turn injection, and with the outputs you can clearly see. And if we remember, our first one was okay. So let's open the whole evaluation, where only one of them passed and the rest failed. 25% pass rate is really bad. So this was the second one, and here you can see the attempt actually worked. So in case you want to figure out which prompts worked where, you go to this JSONL file, but you should also remember that you can copy and paste these prompts, and sometimes it may work and sometimes it may not. Since this one has a 75% chance of working, so the prompt injection worked 75%, which means the actual product was only successful 25% of the time, and I hope that is clear. 25% is the pass rate of our application, and 75% is the failure rate of our application, which means 75% of all prompts injections worked, and the application was vulnerable. I hope this gave you an idea how you can use Garak in your own use cases. If you are running Garak on a powerful machine, the default configuration should give you a baseline of how secure your AI application is. In case you want me to go in details about Garak, tell you about more features and how to use reactive prompts to use AI to scan AI for vulnerabilities, please let me know in the comments. I hope you enjoyed the video, and I'll see you in the next one.